Hello and welcome back to Math with Mrs. Becker. This is calculus, and today we are looking at exponents and power functions, which is our section 0.5. So here we're just going to go ahead and go through some examples and see how much you remember about the laws of exponents. So if it wants me to compute the following numbers, if I have negative 2 to the power of 3, what that means is that I have negative 2 3 times. So negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. If I have 0 to the power of 25, that means I have 0 times 0 times 0 times 0. I have 0 written 25 times. Good thing that we know anything times 0 is 0, because otherwise that would be a really big pain in the rear if you had to write out 25 zeros and try to multiply it. If you ever have a negative exponent, what that does with the fraction is it flips it. So if I have 1 over 2, that negative flips it over, so now it's 2 over 1. When the fraction flips, the negative is gone. Now it's 2 to the power of 1, which is 2. 1 to the power of 1, which is 1. 2 over 1 can be written as a 2. 81. If you have 81 to the 0.75, that is 81 to the 3/4 power. Remember, if you have a fraction exponent, the denominator is your index. So this is the 4th root of 81. Then you take it to the exponent, whatever's on the top. So the 4th root of 81 means what number times itself? 4 times gets you to 81. Well, that's a 3. 3 to the power of 3 is 27. Same thing here. If you have a fraction exponent, the denominator is the index. So I have a cubic root of 27. The numerator is whatever you take that root to the power of 2, or to the power of. In this case, it's a 2. The cubic root of 27, what number times itself 3 times gets you to 27? Well, that's a 3. 3 squared is 9. So just some quick review. Okay, other laws of exponents. If you have an exponent inside and outside of parentheses, you multiply them. When you're multiplying fractions, remember that you can cross cancel. So this 5 on the top can cross off this 5 on the top. I can cross cancel. I can divide them both by 4. 4 divided by 4 would become a 1. 8 divided by 4 would become a 2. So what I really have here is 9 to the 1/2 power. You do not want to leave your exponents as fractions. So this is a square root of 9 to the power of 1. Remember, if it's a power of 1/2, that's the same as just taking the square root. The square root of 9 is 3. If you have the same base on top and bottom, what you have to do with the exponents is subtract. So 5/2 minus 1/2. I have my common denominator, it's a 2. 5 minus 1 is 4. 4 divided by 2 is 2. So this ends up being 3 to the power of 2, which is 9. Again, if you have exponents on the inside and outside of parentheses, you multiply them. So 1/2 times 0 is 0. Anything to the power of 0 is 1. If you have 0.5, that's the same thing as 1/2. 1/2 is the same thing as a square root. So this is a square root of 20 times a square root of 5. You are allowed to multiply radicals together as long as you have the same index. These are both square roots. So it's a square root of 20 times 5, which is 100. And the square root of 100 is 10. So it's all of those exponent properties just mumbled and jumbled together in one section, just to make sure that you have a solid foundation of how this works. Now these, we were just working with numbers. All of our solutions, we had a numerical solution. Well, sometimes you're going to be dealing with exponents and algebraic expressions, meaning your answers are not going to be numerical. You're going to end up with variables. In order to simplify, you have to make sure that your final answer does not include parentheses and you have no negative exponents. So if I look at A, I cannot leave this as an answer because I have parentheses. So what you do is you have to multiply inside and outside exponents. So this is x to the 1/3 of 6 is 2. If you have a negative exponent with a fraction, you flip the fraction upside down. The negative is now gone. That exponent goes to both the top and the bottom. So this is y squared over x squared. If you have coefficients, numbers in front of the variables, you do need to treat them like a normal fraction. If you can simplify and reduce, you have to. I can divide both 3 and 15 by 3. So I would have a negative over 5. You cannot have x's on both top and bottom. This is where you subtract. If you have a variable without an exponent, it's an unwritten 1. So here, I need to take 1 minus 4. 1 minus 4 is negative 3, so you show the 3 as a positive on the bottom. The top ends up being a 1. So I reduced negative 3 over 15 to negative 1 over 5. 1 minus 4 was a negative 3. That's why x cubed is on the bottom of the fraction. Here, if you have a negative exponent on the bottom, it would show as a positive on the top. So if you have a negative on top, it goes on the bottom, and the negative goes away. If you have a negative on the bottom, you put it on the top, and it goes away. Okay, next one's a little bit tricky. If you have a 1/3, that 1/3, what it means is you are taking the cubic root. So I need to take the cubic root of both the top and the bottom, because remember, the exponent goes to the top and the bottom. I have the square root of x out front. The cubic root of 1. What times itself 3 times gets you to a 1? Well, that's a 1. The cubic root of 8. What value times itself 3 times gets you to an 8? That's a 2. A cubic root of x cubed. The cubic root and the cube would cancel. So this would be 1 over 2x. When you multiply fractions, it's top times top, bottom times bottom. So the square root of x times 1 is the square root of x. 1 times 2x is 2x, and we're done. We can evaluate functions that contain that contain exponents. They also contain variables. If I have f of 4, what that means is I'm going to go here, and wherever there's an x, I have to put in a 4. So 4 to the power of 3 means 4 times 4 times 4. If I take 4 times 4 times 4, my solution is 64. Here I have 4 to the negative 1/2 power. This is the same thing as 4 over 1. So the negative is going to flip it upside down. So it's 1 over 4 to the positive 1/2 power. A power of 1/2, what that does is it is a square root. You have to take it to both the top and bottom. So I have the square root of 1 over the square root of 4. The square root of 1 is 1. The square root of 4 is 2. So that ends up being 1/2. For C, anything to the power of 0 is 1. Last idea for 0.5. If you are calculating what's called compound interest, you have to use the compound interest formula. It is A, the amount that you would have, that's the ending amount. P is the principal. How much money are you starting with? How much money are you investing or bringing to the bank? 1, because you get 100% of your principal back. Plus R, your interest rate as a decimal. N, the number of times the money is compounded per year. And then it's N times T. So the number of times you are compounding times your amount of time that the money is being invested or held in the bank, and T is always in years. So let's go ahead and do this. If $5,000 is invested at 8% per year and it's compounded annually means N equals 1. What is the amount after 3 years? So I'm starting with $5,000. 1 plus. 8% as a decimal is 0.08 divided by how many times is it being compounded per year? Annually, so it's a 1. 1 times how many years? It's 3. Well, obviously I can simplify this down a little bit. I have 5,000. 0.08 divided by 1 is 0.08 plus 1 is 1.08. 1 times 3 is 3. So if I put this in my calculator, I have 5,000 times 1.08 to the power of 3. Your account balance at the end of the 3 years would be $6,298.56. So the scenario is you drop off that amount of money and you invest it. You don't touch it. 3 years later, you come back and say, hey, I'd like my money. They're not going to give you $5,000. They are going to give you $6,298.56. So if you were ever asked a question, how much interest did you make? That means how much money did you make on your money? To find that, you would just subtract your original $5,000. So what you made on this deal was $1,298.56. Not too bad for only 3 years. Next one. Suppose that $1,000 is deposited into a savings account. It pays 6% compounded quarterly. Quarterly means that N is a 4. 4 times during the year, you get money added to your account. If no additional deposits or withdrawals are made, how much will be in the account at the end of 1 year? So you are putting $1,000 in the bank. It's 1 plus. The interest is 0.06 divided by 4 because it's the number of times that you are having money added to your account. Then it's that 4 times how many years are you keeping it in the bank? 1. So again, I can simplify this a little bit. When you put this in your calculator, it's 1 plus. You need to open a separate set of parentheses. Okay, so I'm going to go ahead and show you how to do this. So I have 1,000. Open a parenthesis, 1 plus. Now open a parenthesis. I need to take 0.06 divided by 4, close it, close it. The reason why you need to close twice is because one of your parentheses is closing your division. The other parentheses is closing the parentheses that come right after the principal to the power of 4. So this time I didn't make too much money at all, but you only kept it in a year. $1,061.36. So that's what the account balance would be. The amount of interest you made $61.36. Okay, let's look at another one. A corporation issues a bond costing $200. It pays interest compounded monthly. Monthly means that N is 12. So you are getting money added to the value once a month. The interest is accumulated until the bond reaches maturity. If after 5 years the bond is worth $500, what is the interest? So this one stepped it up quite a bit, guys. We have to go backwards. So we know what the ending amount is. The value at the end is equal to 500. We started with 200. It's 1 plus. We're trying to find the interest. It's 12 times per year. 12 times 5, this is 60. Okay, so what I need to do, holy smokes, I need to solve for R. Well, I want to isolate this. So this sounds crazy, but I need to take the 60th root. In order to cancel a square, you got to take the square root. In order to cancel a cube, you got to take a cubic root. So if I'm going to cancel an exponent of 60, I need to take the 60th root. But first, this is 200 times that. So I need to go ahead and divide both sides by 200. So 500 divided by 200, we have 2.5 equals 1 plus R over 12 to the power of 60. Take the 60th root of each side. So to do that, I need 60, whatever your root is. You put that first. Then it's second caret symbol. This little x means that the 60 goes here. So I need the 60th root of 2.5. That is 1.015 equals 1 plus r over 12. Next, I'm going to minus 1. So I have 0.015 equals r over 12. Multiply both sides by 12. Your r, your interest rate, I have 12 times 0.015. It is approximately 0.18. So that was an 18% interest rate. So being able to use that formula not only forwards but backwards. Here we knew the ending balance, we knew our principal, we knew the amount of times it was compounded per year, we knew how long it took to reach maturity. So by doing that, we could figure out if this was a good deal or not. And I could tell you 18%, that is an awesome deal. Okay, so being able to use that formula forwards and backwards is one of the goals for 0.5. Here is your suggested assignment. Don't panic that it's 45 questions. Some of them go so quickly, you guys. You're going to have some questions like 2 to the power of 0. Well, that's 1. 3 squared, that's 9. So I would never give you 45 questions if it was super time consuming. So don't panic. Just get on the ball and get going. I'll talk to you later. Bye-bye.